Good day, I am Elly and today I will be presenting my FYP Scalable College Hostel Voting System using Polygon technology. Chapter 1 consists of introduction, problem statement, objectives, methodology, scope, significant projects, project schedule, and expected outcome. Firstly, the introduction is divided into 3 points, which are how blockchain accommodate a wider range of students to use a voting system, and Polygon acting as a solution to Ethereum's problems, which include high gas fees and slow transaction time, as well as how well will Polygon work in an online voting system. The problem statement highlights on the scalability issues that are present in blockchain in regards of Ethereum, equating that Polygon technology as a solution to solve Ethereum's weaknesses in order to create a scalable residential college voting system. For the objectives, number 1 is to develop a voting system in blockchain using Polygon. Number 2, to design a voting system in blockchain using Polygon. And number 3, to evaluate Polygon-based voting system. The methodology used for this project is waterfall that started with requirement, the design, the implementation, the verification, and lastly the maintenance. This is the scope of the project, which is the hardware involves laptop and desktop, and software involves Visual Studio Code, Remix Online IDE, Web3.js, Polygon Network. The significance of this project is to enhance existing voting systems that are more scalable for students to vote on, and for students to experience a secure environment for voting. This is the project schedule. The expected outcome of this project at the end is having voting system for residential college using Polygon is developed. Moving on to the chapter 2, which is literature review. So we will be focusing on the background study on blockchain technology, the background study on online voting system using blockchain, the scalability issues for blockchain application using Ethereum, and approaches on overcoming scalability issues using Polygon technology. The concept of cryptocurrency, later known as blockchain, was first proposed by the researcher who wears a pseudonym of Satoshi Nakamoto in 2008. In simple terms, a blockchain can be visualized as a form of a ledger that cannot be tampered with. It has two types of blockchain, which are the public and private network. So this is the background study on online voting system using blockchain. Clement Tan Zhengwei and Chua Taiwan 2018 proposed that e-voting system can be made more secure and each voter's privacy can be protected by incorporating blockchain technology. And this is the figure of pre-voting, the ongoing voting session, and the post-going session of voting. Scalability issues for blockchain application using Ethereum. On this particular subtopic, it engaged to more in-depth of Ethereum scalability issues in terms of expensive gas fees, low user throughput, and slow transaction time. A blockchain application platform called Polygon offers sidechain with hybrid proof of stake and plasma functionality, which offers two-layer solution to Ethereum's scalability issues under the subtopic of approaches on how we overcome the scalability issues using Polygon technology. This is a table showing the advantages and disadvantages of Polygon, in which the advantages of Polygon possess a fast transaction processing in average of 2.1 seconds and low transaction fee of $0.01 per transaction. As for disadvantages of Polygon, it is not a self-sustaining blockchain because it needed Ethereum to run, as well as a Polygon currency called Matic token is not utilized to everyday transaction that other digital currencies offer. As for the table here, it is a comparison between Ethereum and Polygon in terms of transaction per second, gas fees, and average block time. For the chapter 3 is requirement analysis and design, which include requirement planning, system design, and the summary. Moving on, the requirement planning involves analysis, functional requirement, non-functional requirement, and system software. As for the system design, it includes use case, sequence diagram, activity diagram, ERD, and graphical user interface or GUI. As for the use case for user, it includes login, logout, view voting result, casting votes, view profile, and view announcement. As for the use case for admin, this is the login, the register candidate, publish voting result, receive voting count, publish announcement, edit user details, and log out. This is the user sequence diagram for register, and this is the sequence diagram for user in the voting part of the system. This is the sequence diagram for login for admin and user. This is the activity diagram for user. And this is the activity diagram for admin. This shows the ERD of the online voting system, which include the user, the candidate, the admin, the vote, category, and election. This is the system design or the user interface design for the index page of the online voting system. This is the user design interface for user homepage. This is the user interface design for candidate categories. And this is the candidate voting page for user. As for this one, this is the user interface design for admin homepage. This is the election page that includes the view voting count, registered candidate, schedule election candidate list, publish result, and edit candidate. This is also a user interface design which shows the user details page. Moving on to chapter 4, implementation. It includes implementation environment, the admin, and the user. As for the implementation environment for this project, it includes the Visual Studio Code to code the HTML, the CSS, the JavaScript, and XAMPP to run the code into the web browser, the Remix IDE to run the smart contract, and the MetaMask to connect it to the Polygon test network. This is the final design of the admin homepage. This is the register candidate form to enter candidate details into the database. So the database will show the candidate details on the user side of the system. And this will be the candidate list inside the admin. The candidate list also includes the option to authorize candidate using Polygon. It can be started by connecting the system MetaMask Polygon test network and then fill in the public address and the metric number of the candidate, then submit it. The metric number will then be stored inside the smart contract or blockchain. This is the final user interface design for user. This is a college page which shows the residential colleges that exist in Unimas. The purpose of this page is to give user the option to select their respective colleges before casting a vote. This is for the user to cast a vote, which includes the candidate details being displayed and the vote button is on the side. This is the candidate categories, and this will be the user profile. Now for the project testing part, it includes the functionality testing and the non-functionality testing, as well as the usability testing. The functionality testing, for example here, a table shows that the admin candidate details submodel. It includes the test case of add candidate, remove candidate, and authorize candidate, as well as display candidate. And as for the non-functional testing, it includes the system response time, the login authentication, availability, readability, and the security of the system. The usability test is conducted by sending out Google Form for user to give feedback on the residential college online voting system. Chapter 6 is the conclusion and future work, which include the achievement objectives, limitation, and future work. The achievement objective firstly, to develop a voting system in blockchain using Polygon is achieved by being developed to design a voting system of blockchain using Polygon. The system has been designed and implemented and evaluate Polygon-based voting system. It has been evaluated. Certain elements of this project still have its own limitation, which includes the enhancements are needed for certain aspects of the user interface. The user and admin do not have the option to edit the profile. The system is specifically tailored for larger screen sizes such as laptops, and the user votes are not saved into the blockchain. On future work, the enhancement can be made to specific elements of the user interface. The system should be designed to accommodate small screen sizes, allowing users to conveniently view and manage it on mobile devices. The functionality to edit profiles should be implemented, providing users with the ability to modify existing information. Also, the blockchain capturing still users' votes should be implemented. That's all from me. Thank you. Hello, today I will demonstrate the live website for this project. So we will go to the admin first. So click login, fill in the email and the password, and click sign in. This is the admin homepage, which include the quick button of add candidate, add user, add election, and the announcement to be written here, and the post button here. And this is the post history, history of election, and history of result. So we will try to navigate into the election. In the election page, it will include the button of View Voting Count, Register Candidate, Schedule Election, Candidate List, and Publish Result. As for the View Voting Count, we will see first. This is the result page, view result for admin. So go to the register candidate, like this one, candidate photo, candidate name, metric number, residential college position, and date. So we will click choose file for the candidate photo, for example, profile picture for this band, Elly, my name, metric number, yeah, Dahlia. So human resource. For choose the date, click submit. We'll show the candidate list here. And to authorize me, for example, metric number, copy the metric number and click authorize. Firstly, we will need to connect to MetaMask. And this and your candidate will be registered successfully. And the candidate will be authorized successfully. And the user password is the circle, user details here. And we'll log out. So this is for new user. We will go to the sign up button. So we say this is user 1, user second.com, metric number is 22211 from Champaka, and user will be then the account activated. Say this email will be activated and the account can be ready to use. So we log in using this email. And this is the user home page, where the quick button is the vote result and logout, and this is a place for the admin announcement to be displayed to the user. It will contain updates, information, or newest news. So we will navigate to the vote by choosing our preferred residential colleges, which is let's say Alamanda here. There. And this is the candidate categories. Cultural representation, representative, the human resource representative for now, and the candidate details will be shown here. So we will place a vote, for example, and it will say the candidate was voted, and it will go back to the user homepage. So this is the place to view result. The differences between the admin and the user can only see the displayed result which the admin has published. It cannot delete or update the result. So yeah. And this is the user profile, which include the name, material number, college, and our photo, default photo, profile photo here. This is the sign up, the profile, and we'll go back to the user homepage here by clicking this one, my home, and it's time to log out. So that's all from me. Thank you.